Here I want to tell you about the basic limit laws. And what you're going to use these for is to help you compute lots of different kinds of limits and eventually to help you evaluate some derivatives. Although, to be honest, we mostly use limit laws in proofs and to prove these derivative rules that you'll see later. We don't often use them in direct calculation, but for getting used to doing limits, these are really, really helpful. So first I want to just dive right in and go through a couple of them and tell you why we care. So here's limit laws. And so there's a bunch of them, so bear with me. So first we have the sum law, which says if you take two functions, maybe call them f of x, g of x, and I'll draw some graphs that these might look like. Okay, so maybe f of x looks like, let's make f of x a line with a hole in it. So let's say 1, 2, 3, maybe there's a hole right there. And so now you know that, for instance, the limit of f of x as x goes to a, well, let's take a equals 1, 2, 3. So just bring your finger on over to the point 3 and what's happening to the y values. So I'm going to track x and f of x. Here we go. And you can see as x goes to 3, f of x, the y value is heading towards 3 as well. In fact, I've just drawn the graph of y equals x with a little hole there. And g could be anything. So let's say that, actually, let's just make g a constant function. In the graph, g is equal to 4. It's just a horizontal line. But the limit laws work for any functions, not just f and g. And the sum law says that if you take the limit as x approaches a particular value, in the picture it's 3, if you take the limit of the sum f of x plus g of x, then the answer that you're going to get is the limit of f of x plus, running into my graph there, plus the limit of g of x. So in other words, if you take the sum of those two functions, then the limit of the sum is equal to the sum of the limits. And so here I can even draw what the sum is for you. So since this is just a constant function, g equals 4, the sum is just going to translate this straight line up 4 units. So if I walk upwards 1, 2, 3, 4, there I go. There's f of x plus g of x. And so you can kind of see this is true from the picture, because if I take the limit as x goes to 3 of the blue function f, I get 3. If I take the limit as x goes to 3 of the yellow function g, that's still going to be 4. G is the constant function 4. You add those together, you're going to get 7. And it's not completely easy to see from the picture because I didn't continue to include the scale. But what I've done with the sum is just translating it up 4 units. So you can see that as x goes to 3, the orange function is going to stay up at 7. So it really is the sum of the two limits. And that's going to work whenever you know that the functions actually have limits. It doesn't have to be true when the functions don't have limits. So here's an example where that's not true. Let's take a new function f, and I'll just draw its graph. This is going to be the function that's 1 when x is bigger than 0. And this is going to be the function that's -1 when x is less than 0. and function g, let's make it the negative of f. So let's make function g equal to 1 when x is less than 0 and negative 1 when x is bigger than 0. And so when I look at these functions individually, well, they both have a right-hand limit, 1 and negative 1. They both have a left-hand limit, negative 1 and positive 1. But if I just look at the limit of f as x goes to 0, that limit doesn't exist because the y values aren't approaching a single value. If I look at g, as the limit as x goes to 0, the y values are not approaching a single value. But check this out. Check this out. If I add them together, if I add these two functions together, and what I mean by that is you pick any x value, and the y value is going to be the sum of the two y values. So if I add these two functions together, for any x bigger than 0, I'm going to get f plus g is 1 minus 1 equals 0. For any x less than 0, I'm going to get negative 1 plus 1 equals 0. So f plus g is just equal to the 0 function. So that's a case where this limit law is not true, because the limit of f plus g, that's limit of constant function 0, is equal to 0. But you can't say that it's equal to the limit of f plus the limit of g, because the limit of f as x goes to 0 does not exist. Limit of g does not exist. So be aware of that. These limit laws work when the limits actually exist.